Assalamualaikum and greetings. My name is Shariza and my groupmate is Muhammad Aidil, Muhammad Akmal and Muhammad Azli, and today we are going to present on our project entitled Chiller System. So to start, first I will talk about the introduction of this project. Meanwhile, Aizat will take over on the literature review. Aidil and Azli will introduce on methodology, and finally we will conclude the overall findings of the project. So to explain on background study, I will explain generally on what is chiller system and compare the use of air-cooled and water-cooled system. So chiller system is basically a machine that removes heat from a liquid via a vapor compression, absorption, refrigeration or absorption refrigeration cycles. The chiller may be cooled by water, cooled by air or cooled evaporatively. In a wide range of commercial facilities, including hotels, restaurants, and others, chillers have become an integral HVAC component. This industry has long known that in most plants, chiller devices constitute the single greatest consumer of electrical use. So in conclusion, heat transfer from internal atmosphere to an external environment is supported by a chiller. This heat transfer device depends on refrigerant's physical condition when it circulates through the chiller method. Chiller will definitely act as the heart of every central HVAC machine. So air-cooled chillers are refrigeration devices used to cool fluids or dehumidify air in both consumer and industrial installation. There are two types, a stationary and a portable air-cooled chillers. And to explain a little on water-cooled system is an equipment with a cooling tower where they have been widely used for medium and large installation with an ample supply of water. So water-cooled condensers perform same as air-cooled condensers, but require two steps to complete the heat transfer. First, heat moves from refrigerant vapor into the condenser water. Then, the warm condenser water is pumped into a cooling tower where the processed heat is ultimately discharged to the atmosphere. A water-cooled chiller system have cooling tower. Thus, they feature higher efficiency than air-cooled chillers. Water-cooled system are more efficient because they condense depending on the ambient bulb temperature, which is lower than the ambient dry bulb temperature. The lower a chiller condenses, the more efficient it is. So the problem statement, in many sectors, chiller play an important role. A lot of application in the industry as well as home appliances and other perspective as well. Hence, some information regarding the equipment must be reviewed by engineers to understand and optimize the system. First, engineer must understand the main function of each equipment in the system, the process flow, how to size the chiller system, what are the advantages and disadvantages, what are the application of chiller, and how do we maintain the system. So there goes for the objective of the project, which we must understand the functionality of equipment by giving adequate details of the equipment specification, appreciate the information of process flow by sharing suitable figures and description of the flow, and acknowledge the method of sizing the chiller, recognize the advantages and disadvantages, make research on application of chiller and ways to provide reliability and maintenance to the system. In facilities of management studies, the students were introduced by Dr. Amin to the basic components inside the chiller system, the theory of flow and capacity, the energy efficiency and overall specification of chiller water system. So the related topics on either system in FOM course should enhance our capability to recognize the needs of understanding the chiller system. Hence, the following topics in this slide will be the requirement needed for said objectives to be fulfilled. So I think that is all from me, and I'll pass the floor to Aizat for literature review part. Thank you.
Moving on to the literature review, I will explain on the literature review about water-cooled chiller system. For the first author, the topic is the reliability and availability assessment and enhancement of water-cooled multi-chiller cooling systems for data centers. This paper aims to identify which types of cooling system designs are preferable for highly reliable data centers. Reliability and availability analyses are conducted to assess and quantify the benefit of redundant equipment. The study is carried out by using the constant failure rate and the steady state availability of data center cooling equipment from the field and calculating the availability of the entire system with different numbers of redundant equipment and distribution headers. From this paper, the authors found that the redundant power, infrastructure, and cooling equipment improved the reliability of a data center, and it increased the availability up to 99.99%. For the second literature review, these authors study on the economic benefits of optimal control for water-closed chiller system serving hotels in a subtropical climate. The method used to carry this research is the implementation of variable speed technology to enhance the energy performance of chiller system. They evaluate operating cost savings of a chiller system integrated with optimal control of cooling towers and condenser water pumps. From there, they found out that this technique is proven to save energy performance of the pump and cooling tower. Moving on to the last literature review, these authors focuses on the classification of efficient water-cooled chiller system. They compared the performance of water-cooled chiller and the air-cooled chiller system with several considerations being applied. They could conclude that the water-cooled chiller system has higher efficiency while operating rather than air-cooled chiller system, and water-cooled chiller system is likely more suitable for a bigger power plant building rather than air-cooled chiller system. Now, I will pass the floor for the methodology part to Aidil Imran.
Assalamualaikum. So I am Aidil. So I will be presenting about findings of our project. So we have choose water cooled chiller as our chiller system. So this water cooled chiller features a water cooled condenser connected with a cooling tower. Water cooled chiller can produce more constant performance for commercial and industrial air conditioning because of the relative independence to fluctuation of the ambient temperature. A typical water-cooled chiller uses recirculating condenser water from a cooling tower to condense the refrigerant. A water-cooled chiller contains a refrigerant dependent on the entering condenser water temperature and flow rate, which function in relation to the ambient wet bulb temperature. Since the wet bulb temperature is always lower than the dry bulb temperature, the refrigerant condensing temperature and pressure in water-cooled chiller can often operate significantly lower than an air-cooled chiller. Hence, water-cooled chiller can offer a longer lifespan. The evaporator section of a water chiller is a shell and tube, refrigerant to water heat exchanger. Depending on the chiller's design, either the refrigerants or the water is contained within the tube. In a flooded shell and tube evaporator, cool liquid refrigerant at low pressure enter the distribution system inside the shell and move uniformly over the tubes, absorbing heat from the warmer water that flows through the tubes. To cool a building or process, the transfer heat must ultimately be rejected outdoor or to another system. The total amount of heat rejected includes the sum of evaporator load and compressor work. The sum of evaporator load, the compressor work, and the motor inefficiency. In a hermetic chiller, where the motor and compressor are in the same housing, these loads are all rejected through the condenser. In an open chiller, where the motor is separate from the compressor and connected by a shaft, the motor heat is rejected directly to the surrounding air. The evaporator load and the compressor work are rejected through the condenser, and the motor heat must be taken care of by the equipment room's air conditioning system. To reject heat, water is passed through a cooling tower where a portion of it evaporates, thus cooling the remaining water. A particular cooling tower's effectiveness at transferring heat depends on water flow rate, water temperature, and ambient wet bulb. The temperature difference between the water entering and leaving cooling tower is the range. The temperature difference between the leaving water temperature and the entering wet bulb is the approach. Okay, moving on to the next slide. Next is how to size a chiller. Firstly, we need to calculate the temperature difference, which is the inlet water temperature minus the required chiller water temperature. Based on the standard rating condition table, the inlet water temperature is 54 degrees Fahrenheit and the required chill water temperature is 44 degrees Fahrenheit. So the temperature difference is 10 degrees Fahrenheit. Next is we need to find the BTU per hour. BTU stands for British Thermal Unit. It is a form of measurement that measures energy. The formula is flow rate times 8.33 times temperature differential. So after calculate, the BTU per hour will be 5397840 BTU per hour. Next is to calculate the tons of cooling capacity. The formula is BTU per hour divided by 12,000. The answer will be 449.82 tons. Lastly, in order to get accurate result, we need to oversize the chiller by 20%. So the ideal size will be 539.78 tons. So for the next slide, this is our system design. We'll be using 6 chillers to cool 2 buildings. So large chill water system with 6 or more chiller have different challenges than smaller system. Examples of this type of system are commonly found in campus with multiple buildings, downtown district and mixed-use residential and commercial development. Creating one centralized chill water system takes significant foresight, initial investment, and building development with a multi-year master plan. If the initial plan is built to accommodate many future buildings or load, the early challenge is operating the system efficiently with much lower loads than it will experience when the project is complete. The system may need to blend parallel and series configuration to accommodate the wide range of load and plant experience during phase construction. Another type of large chill water system could actually start out as more than one chill water system. An existing set of buildings can be gradually added to the central system, or two geographically distant chill water systems can be connected. As system load drops, chillers are turned off. Individual chiller unloading characteristics are not as important because operating chillers are more heavily loaded. In addition, practical pipe size limitation starts to affect the maximum size of chill water system. As the system gets larger, it becomes more difficult to accommodate the increasing pipe size, both in cost and in space. Large difference in temperature can help reduce flow and require pipe size. In general, the larger the system, the higher the temperature difference should be. Larger systems are almost always water cooled, so both chill water and condenser water pipe will have to be filled with water. In some locations, it is difficult to find enough fresh water to fill a very large system with water, especially if the chill system is quite distant from the loads. Cooling towers consume water, which can be significant and difficult to obtain in some locations. The search for both locally available makeup water and energy saving can lead to the exploration of alternative condensing sources like lake, river, or well water. In rare instances, saltwater or brackish water can be applied if the system uses an intermediate heat exchanger, or if the chiller is constructed with special tubes. Furthermore, large chill water systems can be challenged by site power availability. Transformer size may be dictated by local regulation. On-site power generation may be part of the project, leading to using higher voltage inside the chilled water system to avoid transformer losses and costs. Alternative fuels for some or all of the chiller may be attractive. To minimize power, large systems must be very efficient. The upside of a large system is the amplification of energy saving. A relatively small percentage of energy saved becomes more valuable. For this reason, highly efficient series counterflow arrangement is popular for large systems. That's all from me. Thank you.
Hello, my name is Azli Shahril and I'm going to proceed with our project conclusion. Firstly, components inside a water-cooled chiller system consist of condenser, cooling tower, expansion valve, compressor, and also evaporator. The function of condenser is to remove heat from the refrigerant which was picked up by the evaporator. Cooling tower used to cool water and is a huge heat exchanger, expelling building heat into the atmosphere and returning colder water to the chiller. Next is expansion valve. Expansion valve is used to expand the refrigerant, reducing its pressure and increase the volume which will allow it to pick up the unwanted heat in the evaporator. And next is compressor. Compressor takes low pressure, low temperature refrigerant in gas form and compress it into a high pressure, high temperature gas. And finally but not least is evaporator. Evaporator is used as function as a heat exchanger. Next, the conclusion for our project is the process of water-cooled chiller system is as follows. First, the chiller provides a continuous flow of coolant to the cold side of a processed water system at a desired temperature of about 15 Fahrenheit. This 50 Fahrenheit is about 10 degrees Celsius. Next, the process is the coolant is then pumped through the process, extracting heat out of one area of a facility as it flows back to the return side of the processed water system. Next, I will proceed with our third conclusion, which is different size of buildings may require different size of chiller. This as told by Ideal earlier, the maybe higher size of building require a higher huge size of chiller. Next is the advantage of water cooled chiller are longest lifespan, quiet operation, energy efficiency, and no open space needed, while the disadvantage are higher cost, more maintenance, complicated installation, and not suitable for drought areas such as the country like Mesir, Saudi Arabia. Next, I will proceed with our discussion. Chilled water cooling system consists of two types, which is air cooled chiller and also water cooled chiller. For our project, we are focusing more on water cooled chiller. Both of these chiller systems have their own pros and cons. Air cooled chiller as house heat from the condenser coil, while water cooled chiller remove heat from chilled water by exhausting the heat to a second isolated water line called the condensed water line. There is general sizing formula when choosing the correct chiller size. This is as told by earlier, and that's the application for water chiller system, such as medical use, industrial uses, and also chiller is used in making the beverages. And next, chiller should have proper maintenance. Chiller are huge machines that work 24 hours in a day. They should be given a good care and properly maintained properly, since the maintenance cost of a chiller, especially water cooled chiller, is very expensive. Since water cooled chiller is highly associated with water, so water treatment must be done regularly to optimize the efficiency of the chiller. Lack of thorough water treatment result in contaminants such as bacteria and algae. Fall of corroded tube can be reduced chiller efficiency and lead to premature equipment failure. It is important to identify what type of chiller is suitable for your building. So we come up with the final conclusion of the project, which is the factor affecting the decision of choosing the chiller are size of the buildings, economic factor, and also the energy efficiency. I think that's all for me. That's all from us. Thank you very much, and thank you for listening.